So for question 54, we're told that we've got this iron 2 hydroxide in solution, and we're asked to find the pH of this solution when I have 0.4 molar iron 2 plus already in solution. They tell us that the KSP for iron 2 hydroxide is 1.8 times 10 to the minus 15. So the first thing we want to do is set up our reaction, right? Iron 2 plus hydroxide is going to go into solution to give us iron 2 plus and 2 hydroxide. And they tell us that we already have a concentration of 0.4 molar iron 2 plus. We want to find the pH. We know we can find pH from hydroxide eventually. So that's what we're looking for here. And I can do that by basically setting my hydroxide concentration as our X. You might be inclined to set hydroxide as 2x because of that coefficient of 2. We don't need to in this case because this is our only unknown. Hydroxide is the only concentration we're looking for here. So we can plug that in as our only X. So next I want my KSP expression. So KSP equals the concentration of iron 2 plus times the concentration of hydroxide squared. My KSP is 1.8 times 10 to the minus 15. That equals my iron concentration, 0.4, times my hydroxide concentration squared. Divide both sides by 0.4. And I get X squared equals 4.5 times 10 to the minus 15. Square root of both sides, and X, which is our hydroxide concentration, remember, X equals 6.7 times 10 to the minus 8 molar. So now I have my hydroxide concentration. We know we can take our hydroxide concentration. We can find POH from that. And then once we find POH, we can find the pH of this solution. And that's what we're looking for. So the next step, right? If this was step 1, step 2 would be to find the POH. POH equals the negative log of my hydroxide concentration. So the POH of this solution equals the negative log of 6.7 times 10 to the minus 8. POH of this solution equals 7.17. Now I can find the pH of the solution because pH plus POH equals 14. So pH equals 14 minus 7.17. So I have a pH of this solution of approximately 6.83. Right, so we knew we could do that because we know hydroxide is in this equilibrium, and we know from hydroxide, once we find that concentration of hydroxide, we can find POH, and we know POH is related to pH. So yes, the solubility of iron hydroxide is dependent on the pH. We could increase solubility by making it more acidic, and we could decrease solubility by increasing hydroxide concentration or making this more basic. So hopefully that helps with question 54.